Hi, this is Unit 2, Lesson 5, equations that are proportions. All right, example 1. I don't know if you're familiar with these, but the terracotta warriors are this amazing architectural find. It's a literally life-size army of soldiers, chariots, and horses that were made out of terracotta clay. And they were buried under this 15-story mound to guard the tomb of an emperor in China around 250 BC. It took 700,000 workers to build these things, and it took them 36 years. So when archaeologists first discovered the tomb, they excavated part of it. They excavated this 40-foot section, and they knew the whole thing was 680 feet in length, but they just uncovered this 40-foot part of it. And in that small section, they found 316 clay soldiers. So they used an algebraic proportion to estimate the number of soldiers in the whole thing. So we're going to do that. So how many soldiers are in the whole mound? That's what our variable is going to be. So we're going to say x is going to be equal to the number of soldiers in the whole mound. You'll have to excuse my horribly messy writing, because when I write on my tablet it's really hard because I can't rest my hand on it. All right, so let's see what we know. We know how many soldiers are in the small section. We don't know how many are in the whole mound. We do know how long the section is, and we do know how long the whole thing is. So we're going to create a proportion that looks like this, two fractions set equal to each other. What I'm going to do is label it. I'm going to say the numerator is going to stand for the small section. So I make a little label like that. And that the denominator is going to stand for the whole thing. Okay, that's going to be where I put the values for the whole thing. And then in one column, in one ratio, I'm going to represent the lengths. And then in another column, another ratio, I'm going to show the number of soldiers. Now, this might feel a little bit much to be labeling it like that, but when you do that, it makes it so that you can put your values in exactly the right spot. So in this first spot in the top left, we want to know the length of the section, and the length of the section is 40 feet. And then in the denominator there, we want the length of the whole thing, which we know, which is 680. Now in our second ratio, at the top right is section soldiers. How many soldiers are in the section? 316. How many soldiers are in the whole thing? We don't know. We're calling it x. Hey, look, it is a proportion. So we're going to solve that proportion by cross multiplying. Whenever we have two fractions set equal to each other, we can cross multiply, which means you take the numerator of one and the denominator of the other and multiply, and that's going to be equal to the other numerator and other denominator. So in doing that, I'm going to say 40 times x equals 316 times 680. And I'm going to write that all out. I'm not just going to do the multiplication in my head. I'm going to show exactly what it is that my proportion gives me. So then I'm going to go ahead and simplify. On the right, I can do the multiplication and get 214,880. Then I'm going to solve for x by dividing each side by 40. And we get x equals 5372. So we know they estimated that there were 5,372 soldiers in the whole mound. Terrible writing, but that's okay. All right, so again, this is a model for exactly what we expect to see when you do your homework, when you do your assessments. All right, example 2, you give it a try. Okay, so I want you to pause the video. Here's another situation that calls for a proportion, so pause the video and go ahead and give it a try, and then come on back, see how you did. All right, here we are again. We got these sculptured heads. What are we trying to figure out? What is the actual size in feet of George Washington's head? So we're going to write that. I'm going to change to a different color because it's a little bit hard to see the green. Then we go to purple. X equals, okay, actual size of GW's head. Okay, on the statue. That's important. Not the size of his actual head. On the statue. And we want to put there in feet. Right? Whoops, important to put our unit. Who knew that double clicking meant it went back to the next one? All right. Oh my gosh, terrible. Okay. Important to say in feet. All right, so now we're going to do our ratio. And you know, what's interesting about these is there's not one right way to do it. There are multiple right ways depending on what you select for each row and what you select for each column. So it could be that you have a different proportion that I do. But if you cross multiply and get the same situation, then you know you've done it right. So I'm going to label it for myself here. I'm going to say actual and Mount Rushmore. Okay. And then I'm going to say we have the scale of the statue and we have George Washington, the man. So here is my proportion. The scale of the statue is 1 in actual life and to 80 on Mount Rushmore. Now we know George Washington's head is actually about 9 inches tall, right? That's what it says. Typical man's head is 9 inches. What we don't know is what's on the statue. So, beautiful. A proportion we're going to cross multiply. 1 times x is equal to 80 times 9. So again, regardless of what your proportion looks like, if it's different than mine, as long as this is your relationship when you cross multiply, you're good to go. So we get x equals 720. Okay? Now, this is what? Let's think back. You think his head is 720 feet high? That doesn't make sense. So let's look back. This says 9 inches. Right? So if we're using inches in our equation, that means this answer is in inches. Right? And we'd like to know our answer in feet. So we need to say 720 divided by 12 ends up being 60. So we know it's 60 feet. So on the sculpture, GW's head is 60 feet tall. That's still pretty darn tall. All right, one more example. This says you try, but we're not going to have you try. I'm going to talk to you about how to do this one. This one is exactly the same as we've been dealing with. When you have a proportion, 2 fractions set equal to each other. And you've got to make sure they're all fractions, that there's no other term besides the single fraction. Now, there can be expressions in the numerator and the denominator, but you can't have something else added to the fraction outside of it on either side. It's only a proportion if it's fraction equals fraction, which it is in this case. So we're going to cross multiply. We're going to say numerator times denominator. And we know that the commutative property says we can do that in whatever order we want. So I'm going to write the 4 first, and then the x plus 8. And that's equal to, if we do the other two, 2 times 3x minus 2. Well, hey, look, that's an equation. You know how to solve that. I'm going to distribute 4x plus 32 is equal to 6x minus 4. Now I want to isolate my variable, and I've got an x on this side and an x on this side. So I'm going to choose one of them. I'm going to subtract 4x from each side. I like to go with the smaller of the two, so my coefficient stays positive. So then we're left with 32 equals 2x minus 4. I'm going to add 4 to each side. 36 equals 2x. I'm going to divide each side by 2. We get 18 equals x. There we go. All right, your homework is to finish up note sheet / worksheet 5. You can see a couple of problems like the one we just did in example 3, and then on the back are some word problems. Don't forget to answer in a sentence, define your variable, use a proportion, and solve it. All right, I'll see you in class tomorrow.